Next up, we have Varun and Neena, who will be talking about applying speech to text to medical transcription case, and specifically what's called SOAP notes, as described in the meetup notes. Uh, Varun, Neena, the floor is yours.
Uh, thanks. Uh, thanks, Sri. Um, Let me share my screen. Just give me a moment, guys. You guys are able to see my screen?
Yes, you're visible and audible.
Okay. My name is Varun, and today my colleague Ina and I will be taking you to a journey of how we applied actually speech to text technology in field of medical healthcare domain in one of our POCs that we did in Imaginia. And speech to text is something that we are knowingly or unknowingly using it in our day-to-day life, whether I'm not sure whether you guys have used dictation mode in MS Word or any other application, or using auto caption option while watching a video on YouTube. At least I have done it many couple of times myself, and or maybe talking to Siri uh, on MacBook. When you speak to it, it actually converts your speech to text in written format, which you can also see on your screen. So today we'll be talking about, as I said, how we try to explore this application of speech to text in healthcare, and and we'll see how we can use this to ease the life of our medical practitioners, and we'll be looking at one of many endless possibilities of use case that we actually tried to attempt. So coming to today's agenda, we'll be hope few of our folks would be knowing what soap notes are. If not, we'll come to it and we'll see what they are, and then we'll on a high level we'll try to understand what automatic speech recognition is, what off the shelf services that are available in the market. We'll also have a quick demo of our app that we built, and what are the challenges that are associated with automatic speech recognition, and what problems did we face, and then we'll move to a Q&A session. So SOAP notes is actually an acronym of subject, objective, assessment, and plan notes. As you can see on the right-hand side of your screen over here, we have different sections, and each section has its different meaning. So the medical practitioners or doctors actually use this document to track the diagnostics and treatment of any given patient, so that they can communicate with other practitioners, or they can use it for their internal references. uh, so in our actually uh, POC, we tried to use this speech to text recognition, and tried to use this technology to fill out our SOAP notes using voice commands. And here we are not just sticking to just using voice commands, but we are actually also trying to showcase you the possibilities of how we can use NLP to identify various patterns in the data, or extract out various information that are available, and will also give you a hint how we can open up a new unexplored path that is there in front of us. So now coming to automatic speech recognition, so if I have to define it in a simple way, I would say it's a method by which we can the system can actually recognize and translate the spoken language into the text, right? So as I'm speaking to a, let's say, a software or a system, what it basically does is it, I'm giving it an audio feed, right? And the microphone actually converts those into an wave format, which is which we pass to our system in a stream manner. So now before actually throwing it to any automatic speech recognition model or any system, we actually try to also clean the noises that are there in the data set. And then once by noises I mean some some there can be few background noise, or there can be few other noises that can be there in the data. So the system should actually clean those noises, and then when we pass the our audio stream to uh, the system in a data format, the system will actually convert those into a text which we can use. So there are various off the shelf services that are available in the market. All the cloud major cloud providers have these speech to text services like Azure, Google, IBM, Amazon, so which are there. And so by online we mean that for using these services, you have to connect through these APIs in an online way, where your stream actually goes to their server and they'll give you the the uh, text result from their servers. There are few offline models that are also available, like which for that you don't need online connectivity. Few of them are like CMU, Spinix, Mozilla Deep Search, and Neosense ASR. So if you guys are also interested, you can also uh, can try them out. It's like very easy to use. If or if you are interested in training your own models from scratch, then Kaldi is a good framework to do that. It's little difficult to use and get and set it up, but yeah, but once you are done, it's a very powerful tool. It's in itself. So for our soap notes application, we actually relied on GCP platform to do so. So yeah, before actually jumping on the demo, I would wanted to tell you that we actually, as I said earlier, we actually also tried to exploit the opportunity to make alliance with the context that is available with us. And Ina will be shortly giving you a good demo about how we are using it, and uh, you know and extract out various informations from the soap notes that will uh, will gonna dictate, like symptoms, drugs, surgical procedures, disease, uh, and yep. So I think uh, I would request Ina, if you can give us a demo, and I'll stop sharing so the platform is yours for.
Sure, Varun. I'll just share my screen. Um, So here's the demo for our app that we have developed for Soap Notes. The main features that it has is, first, it records the notes that so basically when medical practitioner are dictating the notes for or writing the notes for their diagnostic and treatment related for a patient, then what medical practitioner do currently is they type the notes, whereas with this app they can just go ahead and do the conversation, and then that thing their information will be converted to text, and the transcript will be recorded over here. So how the soap notes are classified, subjective, objective, assessment, and plan. All of those have a section individually, and each section gets activated by certain keywords. So by default, all the information goes into the goal section. So what I'll do is I'll start right away. I'll start this recognition so that whatever we speak gets recorded, and accordingly we'll also understand the usage. So by default, whatever we speak will be recorded into the goal section, and in whenever we want to move it to the any other section, like for example subjective or objective section, we can activate those section by saying a few specific keyword. Like for subjective, there will be a specific keyword called add subjective, and when we say that, the data will be then added to the subjective section. So add subjective. Now we'll start adding data to the subjective section. So basically the speech to text, the transcript is being added to now subjective section. Along with this, so as Varun mentioned that we have added few context informations also. So we have main 4 categories over here. One is disease, second is drug, third is symptoms, and fourth is surgical procedures. So any keywords or any terms falling under these 4 categories will be highlighted on the flow as they are encountered. Like for example, if I say paracetamol, it is marked as a drug. It's highlighted over here. Say another example is yellow fever. It's highlighted as a disease. Let's take another example for surgical procedure, biopsy. It's highlighted over here. So basically what we are trying to do is the terms, the major categories of or the medical related terms we are trying to highlight it so that so basically for medical practitioner it's easy to identify those keywords or terms that are being transcripted. So after that we can add data to add other sections as well. Add objective. Now the data will be added to the objective section. So basically what we are trying to do here is it's like a complete easy forum for the medical practitioner, where they do not have to type in their SOAP notes or their diagnostics and treatments. Everything will be added, and there is also a possibility wherein if they want to edit or do any corrections or any changes to the SOAP notes, they can right away do it in these sections, in these text areas, and then basically post that they can save the notes. So if we go to the save notes section, we can see that this is like an old example where we see all the diseases or all the categories like drugs, symptoms, they are being highlighted. Below the notes, you can see a section wherein all the drug names are identified and collected from the note, and their corresponding side effects are mentioned over here. So what we are trying to do here is, it's not just the speech to text conversion. We are trying to utilize the data collected, and one way is, this is one of the example wherein we are like trying to showcase the side effects of the drugs, so the patient and the medical practitioner can discuss those things right away. Another example of utilizing this data is the context addition. So there can be noise in there can be issues with the medical term pronunciations. So we would want to add, and these, some of the medical terms are really difficult to even pronounce also, and they are not like in the normal they are not used in the normal vocabulary or normal conversations. So we have also added a feature of context dictionary. So basically there are 4 categories as we have discussed before: disease, surgical procedure, drug, and symptoms. So this context dictionary, we have scraped a few data sources to collect the data for these 4 things, 4 categories. The data as of now is not exhaustive. It can be increased. But the idea behind collecting this data is to add a bias towards the medical terms. So basically, when these terms come in the transcript, the focus on these terms will be more, so that these terms can be identified and easily recognized by in this in by the in while conversion from speech to text. With whenever a new disease or a new surgical procedure is identified, the medical practitioner, if they are not available in the database, they can go ahead and add it as well. The major Varun mentioned, it's not just about conversion of speech to text. We are trying to create a forum wherein there is there will be a huge scope for the data, for the future analysis. So basically, once we have this data collected, there can be various possibilities of like entity extraction. So basically, once we have this text, we can have text matching techniques, NLP, to extract various entities out of it. Or there can be many trend analysis or pattern analysis using this. I'll just stop this recognition. So this is like a major this is like a major features of this application. Any questions or any questions regarding this, or Varun, would you want to add something here?
Uh, so I think you explained very well, Ina. If let's wait for a couple of seconds if people have some questions related to the demo, and then we'll move.
I have a
I have,
question.
yeah,
Okay.
go ahead, please. Yes.
So we can switch between any of the sections, right? If I'm in objective, I can go to subjective also. Is that correct?
Yes, yes,
Okay. And so it will start appending to whatever I say next.
yes.
Okay. But in case if somehow they think that okay, no, I whatever I have said in this subjective thing is not right, I want to redo it. So can we like say clear and it will clear it and start again, something like that?
That feature is as of now not there, but it can be
Okay.
easily added.
Okay.
It's one of the
Okay.
feature that we were planning to add, but I mean, it's not there as of now, but it is in the future works.
Okay. Cool. There is one more technical question. I mean, so which model did we use to, convert this speech to text? Did we use any of the ready-made APIs or our own model that Khaldi, or
We are
we?
using Google API for this demo, for
Oh,
this product. Yes.
okay, okay. But we have a model like the one working like Google API, or we will be using Google API only.
For now, we are using Google API, but if it's required, then if there's a demand for this, then we can certainly look into training our own model in future. But it's like it's. I
Okay.
think Sri Kumar would be able to better answer this, whether we'll be training our model in recent future or not.
I mean, making our own ASR engine is a very non-trivial activity to start with, especially if you're
Yes, yes.
looking at a specific vertical to address. And there's been considerable work that's been poured into most of the commercially available API-based ASR tools, both from Google, Microsoft, and AWS. When all of them have poured in considerable amount of work. So it would be what do you say, sort of inappropriate to not first leverage them before deciding to do any further work and deal with some of the issues via post-processing. As you can tell here, like for example, which is also part of what I wanted to ask, if you guys want to address that, which is that there are plenty of errors almost on a line-by-line basis
Correct.
as you are dictating.
Yeah.
I mean, what do you think is the reason for that, and what can we do to reduce that? Because in the context of a medical note, like for example, where they do not have to type in the blood, okay, like in the second line, right? So I mean that would be a fairly serious error, because it can be I mean, could be misread, like I'm just speculating, could be misread as something to do with blood type, uh, for example. Yeah. So since the dangers of miscommunication here are very high, how do we, what do you see as the reason for these kinds of errors coming in, even given that we are using pretty much what the world considers to be the state of the art ASR?
The main it's mainly Shri, is due to diverse voice patterns of humans, which model is still learning to, or it's adapting. Hence, generally to avoid these errors, the user actually has to adjust his pace by slowing it down. So if we reduce our pace, so generally we see lesser errors. And the second way is, as Ina was mentioning earlier, if we can add, if we see that it's related to specific keywords, then we can actually go ahead and add those in context, which may be related to our domain. For example, if they are similar sounding words and or phrases which uh, appears in all different contexts, but one of them is majorly, or most of the times is being used in our domain in which we are interested in this case, like medical or healthcare domain. So we can actually tell the API to actually giving us little bias towards it, so that when we speak that word, the model will start recognizing the correct term in which the way we want it to be. So actually, yeah,
So that's related to the additional context words that you showed,
yes.
right?
Yes.
Hey, just curiously, might be a moot point, but while you were talking and it was converting to text, I saw that many a times it would go back, delete a few words, and redo it again. What was happening there? Was something?
So basically, how it works is until it's able to identify the correct. There is a.
So we are actually
Yeah.
using the streaming API for that. Uh, and once it keep on you know uh, creating text on the partial stream that
Oh, I
it
see.
has received, and once the sentence gets completed based on the pause, it actually changes.
Oh,
And
I
all
see.
the magic
Okay.
of editing was based, was you were looking, we used JavaScript for that.
Oh, okay.
So it's like it maintains a little bit of a window of prediction of what the text is. Then
Oh, I
up
see.
to this point, and then it can edit that as it knows, as it comes to know more,
Oh, I see.
hear
Okay.
more.
Okay.
Yep. So basically, it corrects previous word if it identifies as it's trying to identify the following words. It may go back and correct previous words also based on the context.
Uh-huh. Mm.
Uh, so, Ina, or guys, do you have any other questions, or you want us to move to, like, the though we have already discussed many of the issues that we faced, if you guys have any other questions? No? So, yep. As we were already discussing some of the challenges. So, as you guys might have known that as also Shri highlighted, that there were couple of places where our framework identified couple of keywords as incorrectly. Like at least I noted down couple of them. Like highlighted was you know uh, transcripted as counter light, or section heading was will be had become section wedding. right? So like there are various challenges that are associated to it. Few of them are like accent and local differences, how we pronounce the a particular word, and on which data the on which accent the actually the model was trained. It also is, gets affected based on background noises. Generally, we have seen that if you are talking directly to your system, then the chances of noise is increased, whereas you are using headphones. So with headphones, the noise get cancelled a lot. It also has, the problem over here is also misinterpretation, and context awareness is also missing, as we have already seen. Though we are trying to overcome these problems by adding more context and giving more bias towards a particular keyword related to our domain and problem. So like we have seen that section heading became section wedding, right? Another is time and lack of efficiency. So it's like we usually assume that any computerized process would be speed it up everything, but unfortunately this is not always the case with our when it comes to voice recognition systems. So as I was saying, it is mainly because of diverse patterns of how human speaks, and the models are still learning and adapting to it. So generally, you know if some few people speak very fast and rapid manner, and few their pace is quite slow. So generally, if you speak or adjust your pitch and speed and slow it down, then we have seen that the accuracy generally increase. Privacy and data security is also a challenge in terms of uh, uh, in terms of that you might have to save data that for big systems, or enterprise solutions of the users, whether it's for training purposes or it for post analysis. So this is something that cannot be ignored and it still has to be acknowledged. uh, so, and there are like couple of developmental challenges that we faced. Sometimes we've had seen that if there is a network delay from front end to back end, and then sending the voice streams to, since we were using Google Cloud Platform, and sending those streams to Google APIs. If there is a network delay, then it again messes up everything. Also, setting up audio streams from backend and transforming it into correct wave format, which the model takes, is also a little difficult task. So these were like couple of challenges that we faced, and it took for the second one, it took like 1 or 2 days for us to actually set it up in right format.
One quick note. I recall in an earlier conversation you'd mentioned that the accuracy of transcription reduces when you're actually using Zoom, like when you're doing a demo on Zoom. Whereas if you do it when you're doing it normally on the device, you get better results. I mean, did I recall that correctly, or?
Yes, Shri. That is something that we observed, because when it there can be many factors related to it. Like as I said, if whether you are using headphones, or whether there is again some network get diverted into various things. So yep. This was like this was based on the observations that we you know
Just one speculative thought on this. Uh, um, with respect to post-processing the transcription that Google sends back to us, to determine what to actually insert into the text. I'm wondering whether some kind of causal predictive model like GPT, right, can be useful in that kind of a context. So you've got a bunch of words in history, and if you're able to predict what's going to come up next, at least give a number of predictions, and then match up what's being said against those predictions, and that may be useful to. I'm not speculating that it'll be useful. I'm just curious about whether that will be a useful corrective addition to the ASR itself. Um, yeah.
Interesting point, Shri. It seems that yeah, this is yeah, there's certainly some scope of testing out on if we can add some external mechanism to actually more fine tune the results. Then yeah, you know. Yes.
Varun, I have one question. So when you only tried with this uh, Google ASR or played with any other providers, and that's one part. And another is when you send this. This is right now happening real time, kinda, right? It sends bits. How is it happening? Or if you are sending a bunch of a few seconds or a few minutes of audio, what are the things it sends back, or what are the metadata it has? For example, whether we can able to find out the which each words are located on this seconds of this audio, like that, all that information is available from the API, or how much explain how much descriptive the APIs are, or information it gives.
Right. Good question, Hari. Actually, before actually deciding on GCP, we did some sort of experiments with all the cloud providers, and we also computed the word error rates for that. And we found, based on our experiments, we actually found out that GCP was performing better. We also tried one of the open offline model, CMU Spinx, which you can plug in with your Python code. But it was not performing up to the mark, so we kind of dropped all those and then stuck to GCP. Then coming on to your next question, so it actually also provides a couple of other features, like GCP also, this speech to text APIs also provide you other alternatives. It not only gives one prediction for a stream of data, but it actually provides some alternatives as well, which you have to configure into the system to the API, and you can actually also check what all other alternatives that are being recommended by the GCP. Coming on at which second which word appeared. So if I remember correctly, those cases are generally with when you are uh, uploading a audio file to the API, but for streaming API, I think it does not provide that information.
Yes. Yeah. So the streaming delay, in the sense of how much chunks it takes at a time. Any idea on that model side? What's API side?
So now again, in streaming APIs, there are like various methods that takes different chunk size, or we call it at hertz out frequency, like 1600 to it starts from 8000 to I think 42 or 48,000 hertz per chunk.
Okay. Thanks, Varun.
Any other questions from others? If not, I think we can move on. Thank you, Varun and Nina. There was like a fun demo come talk on the topic.
Thanks, Ed.
So so the next, I mean, we have plenty of time, but like, I mean, we can limit it. We can wrap up earlier. But I think about 20 to